This is part 2 of building the David clock. This section deals with all of the wheel assemblies and essentially stacking all of the gears that are going to be required later in the building process. The first thing we do is remove the parts from the carrier, and the first wheel we're going to build is the hour hand. Once the parts are removed, we need to sand each and every tooth of the hour gear. And it's important just to remove the residue left by the laser cutting process, as it adds a little bit to the thickness of the gear, so it can prevent it from turning properly. And it also is a little on the sticky side, so it makes it more difficult for the gears to mesh with each other. And this is not a slow process. It takes a little while to work your way all the way around the gear. But make sure that you just remove the residue from each and every gear. But it's also important not to change the shape of the gear or to remove too much from the gear, because sloppy gears have a lot of friction as well. Once the gear has been completely sanded, clamp it to the jig. And then you can just test fit and make sure that all the parts are going to fit. And when you're done, and you're comfortable that all the parts actually do fit, just add a little bit of glue. You don't need a whole lot. I use a little stick, one of the alignment pins actually, and just apply a little bit of glue to the areas that mesh and assemble it together. Give it a little bit of a press, and you can set that aside and move on to the next gear, which this is the idler gear for the hour hand mechanism. So the dial train, this is the part of the dial train that slows the minute hand down to, so the minute hand turns once per hour, and it's a 1 to 12 gear reduction so that the hour hand turns once every 12 hours. So again, we're going around each of the teeth and making sure that we remove all of the laser residue from the teeth. And now we can remove the previous assembly, set it aside, and clamp down the next gear. So this is, I'm going to use 2 clamps for this. And these clamps that I'm using, I just got at the dollar store. Actually, I think they were $2 at the dollar store. I have probably about 20 of these lying around the shop, but they come in handy for all sorts of things. So again, we're just applying the glue, and here the gears, it doesn't really matter which side is down or up. They work exactly the same both ways. So go ahead, make sure you're getting enough glue but not too much glue, and press it all together. And again, we can set that aside and move on to the next gear. So this is the grate gear. The grate gear transfers the energy from the winder wheel into the rest of the gear train. And the whole clock is designed to turn the energy of the falling weight into a turning motion that's very controlled. The pendulum controls the speed of the clock, and the pallets control the sort of the tick-tock of it. So here again, there's a lot of teeth on this gear, and you're going to have to go around and sand each individual tooth and just remove the residue. It takes a little while, but if you don't do this, it's just going to cause a lot of problems later on when you go to tune the clock. So again, as with most steps, spending a little bit of extra time when you're preparing the parts makes a huge difference when you go to tune the clock. All right, so this one, because it's a little bit of a larger gear, it has a couple of alignment pins just to keep all the gears perfectly stacked. And I just give a little bit of a sand to the end of the alignment pin, just so it slips into the gears a little bit easier. So here I'm just making sure that the pins slide through the gears without having to be jammed in. So now we can go ahead and clamp that up. So we'll remove the now dry glue, dried hour gear off of the jig and place on the grate gear. And again here, it's nice to leave the markings so that you can see them. This gear runs the same either way, but if you put the marking on the mark side down, that way you'll be able to see the markings even when the pinions are attached to this. So we're just going to glue on the pinions with the alignment pins, add a little bit of glue here. And when you're assembling the pinions, because there's two parts to the pinion, it's best to try and align the marks on the pinion so that the markings are both aligned the same way, just to make sure that all the teeth line up and that there's no offset edges on the teeth. So take a quick look at the gear before you assemble it, just to make sure that all the teeth line up and you're not going to be pinching the next gear. So again, we'll set it aside and move on to the next gear. So the second gear is just part of the reduction train. So we use a couple of gears and step down the ratio all the way through up to the escape gear, just so we don't have to have giant gears with tiny pinions. So it's just a compounded gear train is essentially what a clock is. So again, you'll get very used to this over the building of the clock. A lot of sanding and getting each tooth. And I've also done this just sort of setting the gear off the edge of the table and working vertically as well. But however you manage to do it, it's just folding the sandpaper and running it against each tooth. And afterwards, just you can run the sandpaper around the circumference of the gear just to remove any sharp edges, and that allows the gear to again, reduce friction. So the little bit of extra time you're taking here, you're going to come back to each one of these gears later in the tuning process and in the matching process, but this will speed that process up by spending a little bit of extra time here with the sandpaper. And feel free to use fresh sandpaper anytime you think the sandpaper is getting a little bit dull or used or torn. I usually go through probably 2 sheets of sandpaper per clock I build. So again, now the jig and the clamps are to make sure that each of the gears is completely perpendicular to their axle. And so later, when we assemble them to the axle, that we don't have any wobble in the gear, because wobble in the gear can mean that adjacent gears miss each other and then the clock slips, and correcting that later is more work than making sure that everything is nice and square now. So with the alignment pins, I'm just going to trim them off with my razor saw. Be careful. Pretty much every time I use a razor saw, I wind up getting a cut in my fingertip. Just a little bit of caution here makes sense. And it looks like it's about time for a new razor saw. This one's getting pretty dull. All right, now that both alignment pins are taken care of, what I'm going to do is take the piece of sandpaper. Again, here I'm using 220 grit sandpaper and just smoothing down, making sure that the alignment pins aren't sitting above the pinion, just to make sure that, again, there's nothing that's going to catch or slow down the clock. Friction really is your enemy here. So we'll first do the pinion side, and then we'll flip it over and just check to see if there's any, if the alignment pins went through a little bit too far. We can just sand that down and again make a nice finish on the gear. So that one's ready to go. We'll set that one aside, and we're ready to assemble the second gear. So this one's got 3 alignment pins. We're going to slip that on and clamp it. And again, exactly where you clamp it doesn't really matter. You just want to make sure that it's nice and square to the axle. So again, aligning the pinions, making sure that the holes line up and the marks line up. It doesn't matter which side is up or which side is down. I try to put the mark side down so that they're hidden, so that any of the identifying marks, like the letters on them, are hidden when the clock's finished. So I'm assembling it, making sure that all the teeth are aligned, and then just pressing those alignment pins into the matching holes on the gear below. And I use the sanding block just to save my fingers a little bit. And we'll set that aside, and we can move on to the third gear. So again, we're going to pop it out of the carrier. And go ahead and, yeah, this one's got 2 alignment pins again. And there's the third gear and the escape gear. Both use exactly the same pinions, so it's a common pinion between both of them. And again, we're going to work our way around the outside of the gear. Sanding each tooth and removing all that laser residue. So the laser, when it cuts these gears, it doesn't actually burn. It actually ablates it. It just completely evaporates the wood as it hits. It's at such a high temperature, it doesn't actually have time to oxidize. All right, so we've got all our parts set. We'll remove the second gear from the jig assembly. And again, that axle rod isn't glued into the jig assembly, so you can wiggle it. You can pull out the entire rod to remove the gear and just make sure that there's no glue building up on the axle. And here I go again, removing some axle pins. There we go, all 3 are done. Take the sandpaper to it again, make sure everything's nice and smooth. Perfect. All right, set that aside. And I'm going to move on now to the third gear. Clamp it down. And these clamps, they're not great quality. They don't have a lot of holding force, but it's not really required in this case. All you need to do is hold it in place and make sure that it's flush with the jig. So a little bit of glue, the 2 gears here. We're going to make sure that all the teeth are aligned so that there's no ridges on the tooth, and press it onto the main gear below. Give a little bit of a snug up there. And again, we can set that aside, and now we're going to move on to the escape wheel. So the escape wheel is one of the most important parts of the clock. It regulates the speed of the clock in conjunction with the pendulum, and it stops the motion as the pendulum swings back and forth. The escape wheel and the pallets stop the motion of the clock on a regular basis, so that it can only move at a certain speed. So that the faster the pendulum swings, the more times per second this stop and go motion happens. But it's really important to make sure that this is nicely sanded, and that each tooth, you don't want to change its shape at all, but you want to remove all the residue and any machine marks on this, and be very cautious, because every time that clock stops and starts, which happens every tick, every tock, you have friction to overcome to get it to work again. And reducing that friction is what makes the clock work smoothly and not stop on you in the middle of the day. So most times, or every time the clock stops, it's always because of friction. And the farther up you are in the gear train, so it starts at the winder wheel, and then it goes to the grate wheel, and then it goes to the second wheel, the third wheel, and the escape wheel. So friction at the escape wheel and between the pallets and the escape wheel is multiplied all the way through the gear chain. So this is the most important spot to make sure that there's absolutely no rough edges, there's no residue left, and when it comes time to apply the graphite, to make sure that the graphite is really well applied and everything matches smoothly here. It's important throughout the gear chain, but it's absolutely critical to get the escape wheel right. And I'm just going to use a sanding block here just to make sure that I'm not rounding over any of the teeth faces, because they're very precisely designed to match with the pallets. So again, a little bit more sanding here, work my way around. At least there's not quite as many here, so it doesn't take quite so long. Now there's relief circle areas beneath each tooth, and we're going to clean those up as well, because in the motion of the pallet, as the pallet swings back and forth, it actually touches into those relief areas as well. So I found that the best way to do this, and I'm sure there's going to be comments that people have different ways of doing it, but I just wrapped the sandpaper around a pencil and just work it in and out. You have to be very careful not to, because it is kind of a fragile part. You don't want to break any of the teeth off, so don't force anything, but just slip it in there and twist it back and forth a little bit to remove some of the residue and clean it up and work your way around the gear. So we finally got that done. We're going to go ahead and do the final gear here. Again, this is the common pinion. It's the same pinion that's on the third gear. We're going to sand all the way around. And when we've got all the parts ready, we'll go ahead and get ready to assemble that. So each gear that you work on, you can always work ahead a little bit. You don't want to get too far ahead of yourself, but as one gear is drying, you can sand the teeth on the next gear and sort of prep it and understand how it fits into the rest of the clock. So here we go, removing the, caught my finger there. So we're going to go ahead and sand that, smooth it out, set it aside with the rest of the wheels that we've built so far. That looks pretty good. And assemble the escape wheel. Now here, the escape wheel is absolutely critical that you assemble this the right way. So most of the other gears, if you have it mark side down, mark side up, it doesn't really matter. In this case, it has to be as shown. So it has to be marked side up with the teeth, so you can see the way the teeth are facing. Be very careful about this. And again, we'll assemble the pinions. If you get it wrong, you can remove the pinions and flip it around and put it on the other side. But it's better to get it done right the first time. There we go. So we'll set that aside. So now we move on to the pallets. So again, the pallets are not as complicated. It's basically just a hook that rocks back and forth and catches on the escape wheel to prevent the motion of the clock from just running continuously. So it links the motion of the gear train to the pendulum. So I'm just going to remove the escape wheel and set that aside. And it's very important on the pallets when we get to that to make sure that the faces of the pallets are perfectly accurate. Using a block saves your fingers a little bit here. So again, I'm going to sand down the pins flush just make everything smooth. Make sure there's nothing that's going to snag. And again, I'm using 220 grit sandpaper for all the smoothing out. You can start with 150 and move down to 220, but I don't find that's really necessary in this case. So we got the escape wheel done. We'll set that aside. And now we can start assembling the pallets. So again, I'm going to slip the back onto the pallets, clamp it in place, and apply glue to each of the individual pallet pieces. They're all identical. It's very important that you get them assembled the correct way. So pay close attention to the instructions here. If you glue them on backwards, it will not work. So a little bit of glue, a couple of pins. And again, you want to make sure that you're getting a nice, smooth, even coat of glue, very thin. You don't want it to squeeze out too much. And if it does squeeze out, just wipe it up with a wet paper towel. So all three pieces have been glued up. Just feed them on to the alignment pins. Get them worked up here and make sure that all of the edges are even. That's another pretty key part. Make sure that it's going to adhere completely and press it in place. There we go. I just used a block just to make sure everything's snugged up. All right, pallets are done. Set that aside, and now we can move on to the rewind wheel, the winder wheel. The first part we're going to do is the part that moves with the clock. It's it has a ratchet housing in it, and the ratchets, the PAWLS. And again, this will be familiar to you by now. You're going to have to go and sand all the parts, make sure there's no rough edges, and work your way around the entire winder wheel. I'm also taking some time here with the PAWLS. It's very important for the ratchet mechanism that the PAWLS move very smoothly. So I've twisted up a piece of sandpaper, and I just work it through the axle hole of each of the PAWLS and just sand away any of the residue that's in there. Make sure that they're nice and smooth and there's no machine marks, and that the alignment pins can slip smoothly through them so that they move completely freely. If any of the PAWLS get hung up when you try to rewind the clock, it can actually let the counterweight fall all the way to the ground. So again, this is one of those points where it takes a little bit of extra time here to make sure everything moves really smoothly, and it'll avoid problems in the future. It's a lot harder to go back in and fix the PAWLS after they're assembled. Once they're assembled, it's very difficult to free them up. So again, here I've worked my way around the outside of the gear, and I'm ready to start assembling. So I've got it face side down here. And again, with each of the alignment pins, I'm going to give them a little bit of a sand just to make sure that everything runs smoothly on them. You can actually apply a coat of graphite to them if you want to be extra cautious. I do apply graphite to the PAWLS, as you'll see in a minute here. So each of the 4 alignment pins has been sanded just a little bit, and it's just twirling it, sort of pinching it at a piece of sandpaper and twirling it. We'll do a test assembly here, so you can sort of see how everything goes together. There's a couple of spacers and some alignments. So everything's ready to go. Set the parts aside, make sure you don't knock any of them onto the floor, and we can start assembling. A quick trim of the alignment pins here and a sand. Again, there's no really super difficult steps to building this clock. It's just a lot of taking your time and being patient and making sure that you get everything right as you're assembling through. The instructions are, it's important to follow them very carefully. All right, so we got our pallets done. We'll set that aside. Again, here I just want you to see absolutely that they are aligned correctly. All right. So on the jig, mark side down, clamp it in place. And now you're going to, I'm going to put the alignment pins into the winder base plate here, just to make it a little bit easier to hold it and to put it into place. So I'm applying glue to the unmarked side. That's very important because the marked side shows you exactly how to place the pawls on it. If you place the pawls backwards, they won't work at all. So it's again, important step here. So we'll slide that down, make sure the alignment pins are lined up with the holes below, press them in place. And we're good to move on to the next step. So, next step is the so next step is to install all of the spacer parts. So I try to make sure that the marked side is facing inward. It doesn't really matter here. You're not going to be able to see this part of the clock when it's running, but just to make things as tidy and neat and as possible. So the little Q markings, have them facing the axle here. And just applying the glue to all the faces that are actually going to touch the base plate. And you want to make sure that they're pressed completely in. You don't want them to be sitting proud. Squeeze them all the way in. Make sure that the two sides of the little T there are pressed flat against the ratchet base plate. Once you got everything in, make sure it's all nice and square. Make sure everything's straight. And now what we're going to do is we're going to prepare the pawls. So using the pencil, just apply a little layer of graphite to the pawls. They're small, it's kind of hard to hold them. What I found is it's easier just to set them on a piece of sandpaper and apply it that way. You can do it this way, but it takes a little bit more time. You wind up with a lot of pencil lead on your fingers, and that gets messy. So set it on a piece of sandpaper. It won't slide around as much, and you can get a nice thick coat of graphite onto this. And again, the graphite is a great lubricant for wood. It doesn't damage the wood in any way, and it allows two pieces of wood to slide against each other very easily. And again, that's very important for the pawls. If they get hung up, the clock can unwind on you, which lands your counterweight, which is very heavy, onto the floor. Applying a little bit of graphite into the axle hole, just to make sure that everything slides as easily as possible. I don't know if you can see that exactly, but yeah. So we'll finish up on this one, and then we'll go ahead and do the other three. And again, doing both sides. It actually helps. This is just a pencil as it comes out of the box. It actually helps if you sharpen in a standard sharpener. You get a little bit more lead to work with. And again, you want to, so here we're going to set the pawls as they're done onto the axles. It's very important to match the markings on the base plate below it. So make sure everything's aligned. Make sure that the pawls are inside of the alignment pins. And now we can glue that retainer onto it. So again, we're good. I'm just giving a little bit of a sand to each of the pins here, just so I can press the back plate onto it. Makes the life a little bit easier. So applying glue to the spacers. You want to make absolutely certain that no glue is getting onto those pawls. Again, you want to make sure they're moving freely and they're not going to get glued onto the spacers. Be very, very careful here. And I kind of work my way around. If you've ever changed a tire, it's kind of the same idea. You work one, then you work the one across, and kind of work in a cross pattern just to get the base plate down without damaging it, and work it down evenly onto the spacers. And it's important, again, here that it's completely pressed, that it's inserted onto the spacers. If it's not, then that plate will be non-parallel to the front of the clock, and that can cause issues for winding. You also want to make sure here, while you can, before the glue dries, that all of those pawls can still move smoothly. And when that's done, you can see here that they're all the right way. I've left them for the glue to dry, all touching the center, so that they're not, there's no chance of it getting any glue onto them. So this is the ratchet part of the rewind. The ratchet is attached to the spool, and we'll just grab those parts off the carrier here. So there's two thumb wheels on the outside that just make it a little bit easier to rewind. And finally here we have a part that we don't have to sand each of the gears. There's no gears here to sand, so it's just a little bit of a cleanup, take off any burrs, any rough edges, and we're good to go. The pawl here, or the ratchet, I'm just getting rid of the little carrier marks on it. That was all I was doing there. Again, smooth up in this case, the alignment pins are just being sanded so that they're easier to assemble. So here we go. We got the parts for our spool, and we'll just grab that the front part of the winder wheel off of here with the ratchet housing. Trim up those alignment pins. You can see I pressed one through here, so I'm just sawing it off the front face. I really need to get a new razor saw. Make a point of doing that before the next section of the video. Alright, sand it up again, smoothing everything down, making sure that there's no high spots, there's nothing that's going to snag, nothing that's going to catch on the spool part of the ratchet. And you can see here that all the pawls are moving smoothly. As you rotate it, they'll drop down towards the center. And I'm just sanding the front face because I had pushed that one alignment pin through. So, all good. And here we go. A little bit of glue. Again, you can see I'm not using a whole lot of glue. It's just a nice, thin, even layer of glue over the whole face. Nice and smooth so that not a lot's going to squish out the sides. Press the alignment pins in place so that as we stack it up, they all align properly. And this is one of the parts of the clock that is pretty low precision. It doesn't affect the rest of the clock in any way. As long as you get it all pressed flat, everything's smooth, it's nice and easy. Again, a little bit of coloring inside the lines here. Perfect. Now next goes the backing plate. It's a spacer. And make sure that's marked side up, because that's going to show you exactly how the ratchet goes on. And again, be very careful here that the ratchet gets put on the correct way. If you put it on backwards, the clock won't work. So you can see here, everything's even, everything's pressed together. And I'm not even going to wait for the glue to dry. I'm just going to trim off those pins and give it a sand. Perfect. Set that aside. And now for the last part of the wheel assembly is the pulley for the counterweight. So there's one center part and two flanges. Just sand them up a little bit. I like to take the break any edges. When you say break the edges, it's just any sharp edges on the edge of the wood. You just sand them so there's a little bit of a radius on them, so that when the cord is wound through the pulley, it doesn't catch on anything. So you can see I'm just rounding off the edges there, just smoothing a little bit. All right, a little bit of glue. Again, this isn't a super high precision part. It's something that once you get the three pieces glued together, that's about all you're aiming for. Trying to keep the glue tidy so that it doesn't squish out all over the place. And you're basically making a sandwich of the three parts here, and making sure that all the spokes line up. There we go. Excellent. So here you can see we'll bring all the parts together. That's the spool with the ratchet, the escape wheel. That's the winder. That's the great wheel. That's the second wheel. Hour hand and the idler, pallets, and the third wheel. And I'm just going to show you here how the winder goes together. And you can test it here to make sure that you don't have any problems later on. So get all the PAWLS slipped out of the way. Sort of snap the two parts together, make sure that there's nothing interfering. And then you can sort of test it. You just hold them together and it should turn one way and catch the other way. And you want to make sure that this works very smoothly, so that it's just like a ratchet, like the tool. It works exactly the same way. And that's it. We're ready to go on. The next step, we're going to be fixing the axles to their to the wheels.